Hello friends, welcome back. In this video, we are going to study the examples of the coordination compounds which are named by using the IUPAC rules. That means we have to study the IUPAC nomenclature of the coordination compounds. So let us study some of the examples. So in this example, the first one is the PTCl Cl2NH3 2 plus, right? Now in this coordination compound, first of all we should know which is the central metal atom or the ion, and then which are the ligands, and in that ligands again we should know the positive ligands, negative ligands, and neutral ligands, and also their charges. Okay, so let's see this structure. In this structure, this PT, that is the platinum is the central metal ion. Why it is ion? Because it is having a +2 charge. As it is having a charge, it is named as a central metal ion. If it is having no charge, it will be named as a central metal atom. Then the next one, that is a Cl, that is a chlorine, is named as the negative ligand, and NH3, that is ammonia, is known as the neutral ligand. Okay, and this +2 is the charge on the complex ion, right? Then after getting this information, we should know the oxidation state or the oxidation number of the central metal ion, right? Let us keep this as a X. X will be the central metal oxidation number or the oxidation state of the central metal ion. That is, we have to find out. So for this we require the charges on the ligands. So chlorine is the negative ligand which is having a -1 charge. One chlorine having -1 charge, and ammonia is the neutral ligand which is having the 0 charge. So for the negative ligand, that means for the chlorine, we should write 2. As there are 2 chlorine atoms, it is 2 into -1, which is equals to -2. And then for the neutral ligand having the 0 charge, there are 4 neutral ligands, so it is 4 into 0, which is equals to 0. And hence for the central metal ion, we can write it is X plus -2 plus 0, which is equals to +2, and this +2 is the charge on the complex ion, and hence X is equals to +4. So the charge, or we can say the oxidation state or the oxidation number of this central metal ion, is the +4, right? So we have to write the name of this complex ion. So how to write the name of the complex ion? So we have to first of all write the name of the chlorine, that is, it is a dichloro. There are 2 chlorine, therefore it becomes a dichloro. Then amines, there are 4 amines, therefore it is tetraamine. Then name of the central metal, that is a platinum, and then it is having the oxidation state +4, and as it is having a +2 charge, it is a ion. So at the end we have to write the ion. So its name is, it is tetraamine, then dichloro, platinum, +4 ion. Okay, so in this way, first of all we have to write the name of the complex ion. It is tetraamine dichloro platinum +4 ion. Then the second example is the COCl2En twice plus. So again we have to write this complex ion in this way, and then in this complex we should know the central metal atom or the ion, then the ligands. Again ligands, in the ligands, neutral ligand, positive ligand, and the negative ligands. So this cobalt is the central metal ion. Why ion? Because it is having a plus charge. Then chlorine is the negative ligand, and En, that is the ethylene diamine, which is known as the neutral ligand, and this +2 is the charge on the complex ion. Okay, then how we have to find out the oxidation state or the oxidation number of the central metal ion, which is cobalt. So here let us put this as a X. Then for one chlorine we are having a -1 charge, and for ethylene diamine, which is a neutral ligand, we have to put the 0. Then for the negative ligands, there are 2 chlorine, therefore it is a 2 into -1, which is equals to -2. And then for ethylene diamine, there are 2 ethylene diamine, it becomes 2 into 0, which is equals to 0. And hence for the central metal ion, we can write it is X plus -2 plus 0, which is equals to +1. This +1 is the charge on the complex ion, and hence we can write X is equals to +3. So the oxidation state or the number of this cobalt is the +3. So what will be the name for this then? So we have to write for the chlorine it is a dichloro. Then for the ethylene diamine it is a polydentate ligand. So as there are two ethylene diamine, it will be named as the bis, and in bracket we have to write the ethylene diamine. So it is a dichloro bis ethylene diamine. Then the name of the metal, that is a cobalt, in bracket its oxidation state +3, and finally it is iron, right? So its name is dichloro bis ethylene diamine cobalt +3 iron. Okay, so this is the second example. Let's move to the third example. Third example is the CONH3 6Cl3. So it is the name as CONH3 6Cl3. Again, in this, CO is the central metal for which we have to find the oxidation state. So it will be named as the X. Then for the NH3, NH3 is a neutral ligand, so we have to put the 0, and chlorine. Chlorine is having the -1 charge. As chlorine is outside the square bracket, it is -1. So on the square bracket, we are having the plus charge, right? So how to write the name for the amine or the ammonia? There are 6 ammonia, therefore it is named as the hexaamine and hexaamine cobalt, and the oxidation state will be +3. Why +3? Because there are 3 chlorine outside the square bracket, so it becomes -3. Therefore on the square bracket it becomes +3, and hence on the cobalt it becomes +3. So the name will be hexaamine cobalt +3. Outside the square bracket it is chlorate, right? Okay, so the name is the hexaamine cobalt +3 chlorate. Right? Let us move to the next one. Next one is the COSO4 NH3 4NO3. So for this we can write it is COSO4 NH3 4NO3, right? So in this complex, this cobalt, for which we have to find out the oxidation state or the oxidation number. So it is X. For the sulfate, it is having the charge -2, which is a negative ligand. Ammonia is a neutral ligand, therefore it is 0. And nitrate is having the -1 charge, therefore on the square bracket it is having the +1 charge. So for the oxidation state, we write it is X plus -2 plus 0, which is equals to +1. Therefore, the oxidation state of the cobalt will be +3. So, what will be the name for the neutral ligand? We have to write it is 4 means it is tetraamine. Tetraamine for the SO4, we have to write the sulfato. So, it is tetraamine sulfato cobalt with the oxidation state +3, and outside the square bracket it is nitrate. So, the name is tetraamine sulfato cobalt +3 nitrate, right? So this is the fourth example. Let us move on. The next example is the COClCnNO2 NH3 thrice. So let us draw this structure. In this structure, the CO is the central metal atom. So for this we have to find out the oxidation state or the number. So it is X. For chlorine we are having the charge -1. Cyanide having the charge -1, NO2 -1, NH3 is the neutral ligand, therefore it is 0. So the oxidation number, it becomes X plus -1 plus -1 plus -1 plus 0, which is equals to 0. It is having no charge, therefore it is a neutral ligand, and hence the oxidation number of the cobalt becomes the +3. Then how to write the name? First of all, we are having the neutral ligand. Neutral ligand is the ammonia, and they are 3, therefore it is a triamine. Then the negative ligands alphabetically. So it is chloro, cyano and the nitro, and then cobalt with the oxidation state +3, right? So the name becomes tetraamine. Sorry, instead of tetra here it is triamine. It is triamine chloro, cyano, nitro, cobalt +3. Okay, so this is the name of this complex ion. Instead of tetra, here we have to write the tri. Remember this. Next one is the CdSCN4 +2. Right. So for this complex ion, let us draw the structure. In this structure, this cadmium is the central metal ion, for which we have to put the X. Then SCN, it is a negative ligand which is having the charge -1, and outside the square bracket which is having the +2 charge. So the oxidation number becomes X plus -1, which is equals to +2. So the oxidation number is equals to +2, and hence the name becomes tetrathiocyanato S cadmium +2 ion. Next one is the LiAlH4. Again, here aluminium is the central metal atom, and this is the anionic complex ion. Why it is anionic? Because outside the square bracket we are having the lithium, which is a cation, which is having the positive charge, therefore complex is having the minus charge, and hence it is the anionic complex ion in which the aluminium is the central metal atom, for which we have to find out the oxidation state or the number, therefore it is X. Then for the lithium we are having the +1 charge, hydrogen having the -1 charge. So the oxidation number becomes X plus -4, which is equals to -1, and hence X is equals to +3. So the oxidation number of this aluminium is +3. So what will be the name? First of all, we have to write the, according to the first rule, we have to write the name of the cation. Cation is the lithium. Then name of the anion. Anion is the tetrahydrido, and in between these two we have to put a space. And then we have to write the metal with a special ending. That special ending is the -ate. That is the aluminate, and with its oxidation number +3, right? So the name is, it is a lithium cation tetrahydrido anion, in between these two a space, aluminium, or it is aluminate +3. Okay, so it is a lithium tetrahydrido aluminate +3. Next example, K4FeCN6. In this, it is again a anionic complex ion, because outside we are having the cation, which is having the plus charge, therefore complex is having the minus charge. So let us see the structure. In this structure, Fe is the central metal atom, for which we have to find out the oxidation state or the number, therefore it is X. Cyanide is the negative ligand, therefore -1 charge, and potassium is having the +1 charge. So it becomes X plus -6, which is equals to -4, right? And therefore X is equals to +2. Therefore the oxidation number or the state of the Fe is the +2. So how to write the name? First of all, name of the cation, that is a potassium. Then hexacyano, in between these two a space, and then ferrate. For the Fe we have to write the ferrate, that means ending is ate, and in the square bracket, in the bracket we are having the oxidation state 2. So the name is potassium hexacyano ferrate +2, right? So this is K4FeCN6. Next example is Na2ZnCl4. Again it is the same, that is the anionic type of the complexes. Zinc is the central metal atom or the ion, for which we have to find out the oxidation state or the number, hence we have to put the X. Chlorine is the negative ligand, which is having the -1 charge. Sodium is a cation, therefore +1 charge, and hence we are having X plus -4, which is equals to -2, and hence X is equals to +2. That means the oxidation number of the zinc, that is the central metal atom, is the +2. So what is the name? So we are having the cation, that is the sodium, then anion, that is the tetrachloro, in between these two we are having a space, then metal, that is a zinc with the ending ate, that is a zincate, and in bracket oxidation number +2. So the name is sodium tetrachloro zincate +2, right? Next example, CrEn thrice Cl3. So it is written, in this chromium is the central metal atom, for which we have to put the X. En is the neutral ligand, for which we are having the 0 charge. Chlorine is the negative ligand, which is having the -1 charge. That means as this chlorine is having the -1 charge, there are 3 chlorines, therefore on the square bracket we should have a plus 3 charge. So we are having X plus 0 which is equals to plus 3. This plus 3 is the charge on the complex ion due to the 3 chlorines outside the square bracket. So X becomes plus 3. So the oxidation number of this chromium is the plus 3. So the name is, it is ethylene diamine. It is a polydentate ligand and there are 3 ethylene diamines. So it will be written as the tris. So tris in the bracket it is ethylene diamine. Tris ethylene diamine. Then the chromium in bracket the oxidation number plus 3 and outside the square bracket chloride. And this complex is an example of either D or L. So it is a name as D or L, tris ethylene diamine chromium plus 3 chloride. Next is the CuCl2CH3NH2 twice. Okay, again here we are having the chlorine is the negative ligand which is having the -1 charge. CH3NH2 twice is the neutral ligand, and by using this we are having the oxidation number of the copper is the plus 2. Okay, so what will be the name for this? So it is a name as, first of all we have to write the name of this Cl2. It is a dichloro, then this CH3NH2 twice, it is a polydentate ligand, therefore it is a bis methylamine and then copper with the oxidation number plus 2. So it is a name as a dichloro bis methylamine copper plus 2. Next one is the CrC6H6 twice. So in this example CrC6H6 twice, the chromium is the central metal atom for which we have to find out the oxidation number. Then this C6H6 is the neutral ligand, therefore it is having the 0 charge and hence chromium is having the oxidation state 0. So its name will be, it is a bis. Bis means 2 benzene and chromium is having the 0 charge. So it is named as a bis benzene chromium 0. Next one is the K3AlC2O4 thrice H2O. Okay, so again it is an anionic complex, right? In this complex ion, this C2O4, that is oxalato, is having the -2 charge. Potassium is having the +1 charge. So after this we are getting the oxidation number of aluminium as the +3. So what will be the name for this? So first of all we have to write the name of the cation, that is the potassium. Name of the anion is the trioxalato, and then we have to put a space in between them. Then the metal, aluminium with the ending ATE, and oxidation state is the +3. So its name is potassium trioxalato aluminate +3 trihydrate. Okay, so this is the name of this complex ion. Then AlH2O6 +3. Again in this complex water is the neutral ligand and hence the oxidation number of the aluminium is the +3. So it is a name as hexaquo aluminium +3 ion. Next is the AgNH3 twice plus. In this complex NH3 is the neutral ligand, therefore the oxidation number of the silver will be +1 and the name is diamine silver +1 ion. Next example, AgCN twice minus. Here cyanide is the negative ligand, therefore which is having the minus charge and hence Ag becomes +1. So the name becomes a dicyanoargentate +1 ion. Why it is argentate? Because it is a anionic complex ion. Anionic complex ion, they are having the special ending ATE. Next is the CONH34Cl2 plus. Now here ammonia is a neutral ligand, chlorine is the negative ligand and hence the oxidation number of the cobalt becomes +3. So it is a name as dichlorotetramine cobalt +3 ion. Next is the PbOH4 -2. Again OH is the negative ligand, therefore -1 charge, and hence the oxidation number becomes +2. So the name is tetrahydroxoplumbate +2 ion. Why it is plumbate? Because it is an anionic ligand which is having the minus charge, and hence the ending is ATE. Next example is the PTNH3 twice Cl4. In this example, this ammonia is the neutral ligand, therefore 0 charge. Chlorine is a negative ligand, therefore -1 charge, and hence the oxidation number becomes +4. So the name is diamine tetrachloroplatinum +4. Okay, so these are some of the examples in which we are using the IUPAC rules to name the coordination compounds. In the next video, we will study some more examples. Thank you.